Welcome to another Syvecs help video. This help video is based on our new OEX firmware that is designed to integrate with EcuTek's new CX29 data stream update release. What this basically means is the flexibility now in the interaction between the original ECU and our OEX has just become expanded, and we're going to showcase some of the new things that you can do with that and what you can link them into on the OEX. So let's get started. So on the OEX there are two CAN buses, CAN 0 and 1, and you can adjust the speed first of all here to suit. Now with the OEM installations, generally speaking, they both need to be at 500 kilobits. Once you've got those set, if you do change those values, you do need to program the OEX in order for those changes to be applied, because they are blue items. Anything that's a green item doesn't require programming. So the first step that I would probably look at doing this when you've got a fresh installation, or if you have got existing installation, you can fast forward this bit, is basically setting up the OEM predefined CAN bus select. So for example, if you're fitting this into say a Nissan R35, then you can just go into the predefined list here, select the CAN you want to select this on. So for this particular install, it's on CAN 0, and then go into here and basically select which one you want to use. So we just select that on BMW R35, and then you've got the option to transmit the OEM check light when a limp mode is active. So if there is a limp mode in the OEX like we've got here at the moment for a sensor warning because the sensor is unplugged, then you can actually make it transmit the original ECU check light. It will cause it to flash briefly when there is a limp mode if the OEX is connected to the original powertrain CAN. So once you've got that set up, that will actually allow you to pull in all of the CAN data from the original car. RPM will come from the crank and cam on the OEX if you're controlling additional injectors. If you're not, then the RPM will come from the CAN bus. But your torque values, PPS, TPS, manifold pressure, temperatures, etc. will then get pulled in once you've chose the predefined CAN receive. Then we're going to now go to the EcuTek CX data stream section. So again, you need to select the CAN bus which is going to be applied to. So we've got the OEM predefined CAN bus set on CAN 0, so we need to do the same for this because that means that the original ECU is connected on CAN 0. And then we're going to first attack the receive functions. So there is help on this. If you press F1, it does bring up help, and it does explain the items that can be populated with the receive. You can see them here highlighted and what strategies they link into. But I'm going to just talk about that anyway. So in order to enable the receive, you obviously need to enable this box here. And then after that, you've got the option of basically receiving 16-bit items or 8-bit items. Now, I'm going to showcase here on the screen so you can actually see in the EcuTek software where you select those and how you enable those. And when you're doing that and then you flash the file into your original ECU, it will basically then transmit onto the CAN bus the dedicated frames needed to transmit the items you wanted to see. What you then need to do is you then need to marry up and basically program the CX29 to which one of those items you want to receive. Now, they don't have to match perfectly. What I mean by that is you might be sending, say, mass airflow from the original ECU, but you don't have to enable that to receive it here. It's not actually straight, you don't have to use it. So it's optional what stuff you can receive here. So the triggers basically allow you to pick up the triggers that you can use for like on-off switches that are coming from the original ECU, and you can assign those trigger bits to functions here inside of the OEX. So you could assign them to an auxiliary 1 trigger, and then you could use that auxiliary 1, say, trigger to be linked into a fuel pump control. Or you could link it into, if you go to the output functions here, you could link it into an external controlled output, and then you could basically assign the trigger input there and have it so it's either a PWM or basically a simple on off. So you could have it so it turns on when that value is on and set the duty. You can then link it into custom maps if you wanted to. You could have it so you could make 3D maps and apply custom features on top of that, or link them into existing strategies like the water methanol, nitrous, etc. So we'll come back to the 16-bit receive, and for the purpose of this, we're just going to look at receiving, say, the manifold pressure, the desired boost, look at receiving the injection pulse width for our port injectors, and the injection angle, and maybe let's grab the auxiliary signals as well, because you might be doing some custom functions on the original ECU, and then the triggers, so we can use those things. Now, if you've enabled those same things from the original ECU, then the OEX will automatically pick them up and grab them. Once you've done that, if you are wanting to control additional port injectors externally, we have talked about this before in another video, but I'm just going to briefly skim over it now. You first of all need to assign the injectors you want to use to the pin assignments here, and the same with the wastegate. Once you've done that, you need to set up the engine fundamentals. Now, if we provide a base map for your particular car, that will all be done. You just need to assign the crank and cam in the pin assignments, so you just basically need to tee into the crank and cam sensor, run them into the OEX, assign the pins you've used, make sure it's one of the generic pins that are like 1 through to 6 and then 13 to 16. They can accept a frequency signal, so that's important. Once you've done those and assigned it, you can then program it. It will pick up the engine RPM. You want to make sure your sync state is going into 720 in the top right up here, and you're getting an RPM value. So once you've got that, you can then go into, say, the fuel control, fuel calculation source. Now, if you are not using an ECU like with the OEM features like EcuTek or MHD, where it sends the required port injection out, you can do the port injection control or fire internal maps with multipliers for gears, throttle, fuel pressure, etc. You can also have your closed loop lambda target as well and feed that in from an external source and all sorts. But for the purpose of this, we're actually just going to go and do it as an external thing. And what that will then do is the fuel final target external value. You can see here that item here. If we do a gauge add fuel final external target. Once the original ECU is sending a signal down to basically say how much fuel injection it would like, it will look at this external translation table, leave that 1-to-1, and then it will start driving the additional injectors to suit. You can then adjust your injection end angle yourself manually if you want, or with the latest CX29 stuff, you can also do it externally, and it will then grab the fuel angle extern. Just put it on extern, fuel angle target extern, which then gets fed in, and basically the injection end angle will be set based on that. It is important that when you do that, obviously make sure you have enabled the injection end angle option here, because that is needed. Okay, so then we're going to move on to the 8-bit receive. What this does is basically allow you to pick up a few more things. So you can pick up the triggers from an 8-bit if you want as well. Make sure you don't have the triggers enabled in both the 8-bit and the 16-bit because it will cause clashing. Other than that, you can then receive your desired lambda if you wanted to, your actual lambda, your selected map on the original ECU, and feed these in. The desired lambda, again, that can be actually fed in if you're not using the external control and you are just using an internal logic. You can actually feed that CAN target, the lambda target from CAN in here, and then adjust your lambda target with that as well. Okay, so once you've set up the receive functions now, you've got the ability to adjust the scaling and the offsets of those values, but you shouldn't need to do that with the EcuTek because already we have programmed those values to be scaled and set right. This is just that if someone was wanting to integrate it with another system and then having to be able to adjust those items. The receive timeout is 1 second. If basically no item was received after 1 second from the original ECU CAN, then it will flag a timeout limp on here, and down in the bottom right hand corner it will show you the reason to which items have timed out, etc. Maybe they're not being sent or received. And you might get that if you have not enabled the CX29 feature inside of the EcuTek race ROM. So now we move on to the transmit section. So if we just close this down and then open the transmit section, first of all you need to obviously overall and transmit enable. Again, there is help in here that explains all about this. The mode select. So what this does, on the EcuTek, there's the ability to have 4 modes on the factory ECU to be tasked with certain maps, boost targets, etc. on the original ECU. You can actually set those now from the OEX with an external, say, cow switch. So if you were to wire in a 12-position rotary switch, you can assign that to cow select. Once that's done, you can then select what mode is transmitted up to the original ECU based on the cow select you're in. In order to transmit that, you need to obviously select those in the transmit section in here. So basically in here, you want to fill in the items that you want to transmit. Now this is done in a round robin style of transmit. So if you're wanting to transmit something particularly fast, you want to send it in multiple frames. So for example, if I'm wanting to feed back the injection pulse multiple times, then sending it like that would be the best way, because it will actually then mean that that is going to be updated around about 12.5 milliseconds every time. If you want items that are going to go slower, then ultimately you can just set the one item back. So if you want to say the torque limit, say half that value, you would set that in here. Then again, you can obviously then fill these in with the B and C and the D and E with the items that you want and wanting to send back in. And once you've done that, you then got the ability to set your aux source selection. So what that means, let's say for example, if we choose to send the auxiliary, okay, send it quite fast back to the factory ECU. So we send that every 12 milliseconds back. What you can then do is you can then select the source of that auxiliary. So if you want to send back into the original ECU your, say, water methanol pump final duty or your nitrous control final, you can then select this list and select all of these custom features or items that you can send back up to the EcuTek. It's really useful because you can then link that into custom maps on the EcuTek and it'll be used for nice features. You can scale those items if you want and apply an offset. And then you've got the 8-bit transmit as well. Now, if you are using the 16-bit, what I would say, max out this as much as possible with items you want. And then for the 8-bit, just leave that alone and just use slot F. Because the other ones, it will slow down the transmit rate of the items you can send. So in the slot F, just set in there the items that you want to send back. Say fuel comp. You could send back your auxiliary position, your switch states, 8-bit switches and stuff like that you can then assign here and put this to certain features like fuel pump switches, cal switches, limp mode light, etc. If you want to send the limp mode up, you can do that as well, and you can scale that to suit. Now, one other really cool thing that you can do with the OEX with this latest software, you can basically do, so we obviously communicate with the factory car's CAN bus by connecting to the original car CAN. And from that, we pick up the wheel speeds at an extremely fast rate from the ABS module. That comes into the OEX, and then basically you can use our traction control strategy that is famous in our plug-and-play kit in the OEX. So you can do all of your traction control kind of calculations for your slip targets. You can also link in a GPS sensor. So you could go into here and enable the vehicle speed to come from GPS. So you could basically receive the Syvecs GPS here, and basically on a four-wheel drive car then you've got a solid ground speed, and you can then pick up the four-wheel speeds to adjust your slip targets and torque reduction clamps. Now once you've got that, you can actually then send the torque reduction value from the traction control system, which is called TCTRQ. This is the traction control torque reduction value, and you can then feed that and send that over CAN back to the original ECU, which you can then have it reduced, say, your torque reductions and stuff like that. So in here, you could basically assign that to auxiliary 4, which is a standard, your torque limit here you could set. So we've got the torque limit set here already, and then you could assign that to auxiliary 4. So let's say you want to send back in the TC torque. We're going to set the auxiliary 4 in here. And once you've done that, you can then go into the source selection and you can see it's standardized already to send in the TC torque. The other way you can do this, you can also send torque limit maps back into the original ECU as well via this custom table here. So this custom table default values is based on pedal position and TC torque as well. And you can actually make it so you send a torque reduction target, i.e. the torque that you want for, say, a given gear, or for based on your traction control slip. So what you could make this table to be really good with acceleration, you could make this gear, this axis at the top here, gear, just by going to the view customizing area, and then go into output functions here. So you could make this say gear, so we disconnect while we do that. Put this as your speed, for example, sorry. And then come back out here. And then basically what you could then do, based on your speed and torque reduction amount, you could set an overall torque limit. So you could say, okay, I want the torque to be clamped below 60 to say 600 Newton meters. And then after that, want it to basically go up with speed. That value, once you transmit that via the CX29 transmit option here, and you send in that torque limit value will then go into the original ECU, and the original ECU will limit the torque based on that. So the two work so well because you've got the extremely fast rate of doing traction control via the OEX, and then the torque value, the reduction is sent to the OEM ECU, and it works really well to get these cars accelerating as best as it possibly can. So yeah, this is a brief overview of what you can do with it. Ultimately, there's more and more that we're going to look at implementing as time goes on. If you have any questions, please just email support@Syvecs.